Hello, in this video, I will explain to you on how to solve for P1 here, the voltage across this 10 ohm resistor using nodal analysis. So the goal is to find out P1. Okay, P1. And we need to use nodal analysis. Okay, what we need to do step by step, I will explain it to you. So the first step that we need to do is to label all the nodes in the circuits. Label all the nodes. And aside from labeling all the nodes, we also infer some essential information that we need to solve in the circuit. Okay, now let's set this bottommost node here as our first node, and we use this as our reference node. So this is our reference node, and some other book called it the ground. And what does that mean? That means that the voltage here will be 0. Good. But if this is 0, we can also get this node here, right? Why? Because it is connected by the voltage source here, the 10-volt voltage source. And remember, the voltage source is the difference between its positive terminal and its negative terminal. But then its negative terminal is 0 here. So then we can infer that this node here is 10 volt from the ground, right? Because 10 minus 0 will be 10. And that is exactly the value of this voltage source. Good. And using the same logic, we can infer that this node here is 20 volt. Why? Because if the positive side is 20, right, and then the negative side is 0, the difference will be 20 volt, exactly what we need here. Good. So this node is 10 volt and this node is 20 volt. And I think that is nice because we only have one unknown nodes. Let's name this node here as node VA, but then the voltage here will be node VA. Right? Let's name this node as node A. So the voltage here will be VA. Good. And I think we have done all of that, right? We have labeled all the nodes, and also we had inferred what we need. And then what can we do next? We assume the direction of the current. Assume the current's direction. Okay, what I usually do for the horizontal component, I just make it to the right like this. So the current that passed through this 5 ohm resistor is assumed to the right. And for this 10 ohm also assumed to the right, right? And then for this 10 ohm, it is going down. For the vertical component, I usually going down. And this is a horizontal component, so I assume it is going to the right, like that. Good. And we have done step number 2. Let's do step number 3, which is do KCL, the Kirchhoff current law, for all unknown nodes. Okay, in this case, we only have one unknown node, which is VA. So we only need to do one KCL at VA. Let's do exactly that. So what can we do is we do KCL, the Kirchhoff current law, at node VA. Okay, what does KCL say? KCL said the sum of the current that goes in will equal to the sum of the currents that goes out, right? Okay, let's see in this node here. There are two currents that goes in, right? This one and that one. All the other currents are going out. So for the first current here, the current that passed through this 10 ohm resistor, we can calculate it using Ohm's law, right? So we will have 10 here. The current came from this node here. So I will have 10 volt. And then the current goes to VA. So I'll have 10 minus VA. Okay, but remember we need current, that is voltage. We need to divide by the resistance between them. And the resistance between them is 10 ohm. Good. And now let's move on to this 5 ohm resistor here. The current that passed through it goes to the right. and it is coming from this 10-volt node. So I will have plus 10, and then the current goes to VA, so I will have 10 minus VA. And remember, this is voltage, we need current, so we divide it by the resistance between them, which is 5. Okay, and I think that's all for the current that goes in. Now let's move on to the current that goes out. Let's do this first, okay? And this current comes from VA, so I will have VA. And then this current goes to this 20-volt node, so I will have VA minus 20. But remember, this is voltage, we need to divide it by the resistance between them to get current, so I will have 4. Good, and the last current that goes out is this one here. And that means that I will have VA here. VA is where the current comes from, right? And the current goes to the reference node or the ground, and the voltage there is 0. So I have VA minus 0 divided by 10. Okay, and we can multiply both sides here by 20. Why 20? Because we can cancel out all the denominator. 20 is the least common multipliers of all the denominator, right? Okay, so now let's multiply this term by 20. 10 and 20 will cancel into 2, so we multiply the numerator by 2. So I'll have 20 minus 2 VA. Okay, and then let's move on to this term here. So I'll have 5 and 20. That will cancel into 4. So I'll have 4 multiplied by the numerator here. So I'll have 40 minus 4 VA. Good. And now I will have 4 and 20 will cancel into 5. So I will have 5 VA. And then we will have minus 100, right? 20 multiplied by 5 is 100. And then here I will have 10 and 20 will cancel into 2. So I'll have plus 2 VA. And I think that's all good. Now, okay, now we have to be careful here because we need to do mathematics. Okay, let's do that. 20 plus 40, that will be 60. And then 60 plus 100, I will have 160 on the left-hand side. And then on the right-hand side, I will have 5 plus 2, that will be 7. 7 plus 2. 7 plus 2, that will be 9. And then 9 plus 4. What is 9 plus 4? 13. Yeah, I will have 13 VA. Okay, now what can we do is we divide both sides by 13, right? So we will have VA. VA here is equal to 160 divided by 13. And what is the value of that? 160 divided by 13, that should be 12.31 volt. 12.31 volt. Okay, that is our value of VA, right? So 12.31 volt. Good. But then the question does not ask about VA, it is asking about V1. So the last step will be answer the question. Answer the question. Okay, the question is asking about V1 here. And what is V1? Let's see the circuit here. V1 is the difference between its positive terminal. So we'll have VA there. And then minus the negative terminal. So the negative terminal here is connected to the ground. So I will have VA minus 0, which is the same as VA. Therefore, I will have P1 here is equal to 12.31 volt if I did not make any mistakes in this calculation. But I don't know. Let me know if I did make some mistakes. But thank you for watching. See you in the next video. Bye bye.